So these are all SOHCAHTOA. So it is all going to be your sine is opposite over hypotenuse, your cosine is adjacent over hypotenuse, your tangent is opposite over adjacent. Okay? So then you just label it. Here's this guy. All right? This is opposite. This is adjacent. They want the tangent of that guy. So it's going to be the tangent of theta is 4 over 4, which is 1. Okay? That's all you're doing on this page. This guy, this is going to be opposite. This is adjacent. And this is hypotenuse. So you do have to know your opposites. So the opposite of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Okay? So if they're asking for secant, find your cosine. And then just flip it upside down. Okay? So you are going to have to do Pythagorean Theorem here. So you're going to have to say, to find the hypotenuse, because you have to have it, it's going to be the square root of these two guys, 15 squared plus 20 squared, a squared plus b squared, right? Equals c squared. So that's why I took the square root. 5. That's my hypotenuse. My hypotenuse is 25. All right? If they're asking for secant, I'm going to find cosine adjacent over hypotenuse. So let's find the cosine. That's going to be adjacent over hypotenuse. Reduce it. So divide by 5. So 3/5. And then because we're looking for secant, we're just going to flip this guy. So we're going to say 5/3. 5 wants us to find the angle. Once again, we are going to say which two sides do we have. So if I'm talking about this angle, this guy is adjacent because it's touching the angle. This is hypotenuse because it is across from the right. So I'm going to say which one deals with adjacent hypotenuse? Cosine does. And so I'm going to say, well, the cosine of theta should equal adjacent over hypotenuse. I am looking for the angle. So I'm going to use my inverse trig function here. Anytime you're looking for the angle, you're going to use your inverse trig. So whatever this is, whatever ratio is set up, just put it into your calculator with the inverse if you're looking for the angle. Always use your -1. And you're going to do 53.6 degrees here. I'm trying to find a side. Again, I'm just going to label it. Here's my angle it's talking about. This is opposite. This is hypotenuse. Which one deals with opposite hypotenuse? Sine. Oh, yeah. So sine of 23 degrees should equal opposite over hypotenuse. Anytime what you're solving for is on bottom, you will divide, okay? If it's on top, you'll multiply. If it's on bottom, you'll divide. So this is on bottom, so you're going to say 3 divided by the sine of 23 will give me my side length, okay? If I was solving for hypotenuse there, you would say 3 times the sine, okay? If hypotenuse had been what you had filled in and you had the other one on top, right? Does that make sense? And so when you do that, you're going to get a decimal, and I think it says round to the nearest 1 decimal place. Yeah, so you're going to get approximately 3.1. Okay. So all of the first and second page here is SOHCAHTOA. All right. The next one, while it's a word problem, Brad built a ramp with a height of 3.5 feet. Height. How tall is the ramp? 3.5 feet. All right. The incline is 18 degrees. That means the incline is 18 degrees. How long is the ramp? How long is the ramp? Right, so if this is his ramp, and it goes up 3.5 feet at an incline of 18 degrees, they have given me a right triangle. So I'm going to label that right triangle. Opposite hypotenuse. This is identical to the problem we just did. The sine of 18 should equal opposite over hypotenuse. My hypotenuse is on bottom, so I am going to divide. 3.5 divided by the sine of 18 degrees. And I get approximately 11.3 feet for my ramp. So do you see how those are the exact same problem? It just gave me words. High, that's usually your how far the vertical distance is, right? Incline, that's your angle of elevation from the bottom up, right? Elevation just means if you were to look up, depression if you were to look down, right? Same thing as what depression and elevate mean, in English. So degree conversion is page 233. So page 233 in your book. All right. Remember when you're going from degrees to radians, you're going to multiply by pi over 180. And radians to degrees is just opposite 180 over pi. Okay.
And so, like, for number 16, you would put a 1 under the 360, right?
Yep. Times pi over 180. And that's a beautiful one because those actually cancel. And then you just multiply across. Negative 2 times pi over 1. Right? You would just say 180 over pi. And then you can cross cancel. Your pi's will cancel. 6 goes into 12 2 times. 6 goes into 180 30 times. And actually goes one more time, right? You can actually keep going. Does that make sense? So you could have divided by 12 if you wanted to, right? Just like that. You can keep going. And then you're just going to multiply across 7 times 15 is 105 degrees. And you are done. Arc length. So arc length formula is on page 235. Oh, if I could write a 3, that would be great. All right. It is simply your radius times theta, but theta has to be in radians. Okay?
Like in my calculator or
like... No. You have to convert it like you did the one above it.
Oh, okay.
So like for this, you would normally just say your radius times your theta, but theta's in degrees. Mm-hmm. So you have to say times pi over 180. So just put them all over 1. Right? And then you can cancel, the zeros cancel, obviously. 18 and 24, you have what? 6 goes into both of them. 6 goes into 18 3 times. It goes into 24 4 times. Right, and then you can just multiply across. 4 times pi is 16 pi. 1 times 3 is 3. You are done. 16 pi over 3 inches. Nope, you can't reduce anything else. That formula is on page 237. Okay. This one is 1/2 r squared times theta, and it has to also be in radians. So I would say 1/2 15 squared times 90 times pi over 180. Okay.
Yep.
And then I would just, this is going to be a 1. That's going to be a 2. You can put the 15 in. That's already a 1/2, so you already have a fraction there. All right, so I have 1 on top, 2 on bottom. I have 225, that's 15 squared over 1. And I have pi over 2. Right? And I don't think anything else reduces here, so you just multiply across. You get 225 pi on top and 4 on bottom. And that is your answer.
Did the 1/2?
First one is any angle. So these are 2 different problems here. The first one wants to find the trig function of any angle, not unit circle. Okay? So remember that r is going to equal the square root of x squared plus y squared. Okay? Just like your magnitude, right? Your sine is y over r. Your cosine is x over r. And your tangent is y over x. And then your reciprocals are the same, like cosecant then would be r over y, secant. So remember that you have reciprocals here.
Right.
That just flip them upside down. Mm-hmm. All right. So they're asking for cosine. They want x over your r, right? So you're going to say 4 squared plus 2 squared of 5 squared and take the square root. All right. 4 squared is 16. When you square this, it's just this guy squared, which is, that's not a plus sign. Plus That's 4, and remember when you square a square root, that's just what's inside.
Right.
So you have 16 plus 20, which is 36. The square root of 36 is just 6. So that means your r is 6. So now you just have to put x over r for cosine, right? Cosine is x over r. X is 4. R is 6. 2/3.
And below, yeah.
Pretty much. So when they want the reference angle, they want the closest angle to x. Okay? So if I have a negative 120, that's going to leave 60 degrees to mine, right? So the reference angle question is 60 degrees. We're done. That's all they're asking for reference angle.
Right.
Then they want me to give you the sine. That's from the unit circle. So if you look on your unit circle, what's the sine of a 60-degree angle?
Okay. Is it cosine sine or sine cosine?
Cosine is x, sine is y.
I always forget that.
So the sine is 60.
Square root of 3 over 2.
Yeah. So square root of 3 over 2. Which quadrant am I in? Right here. It's on the picture. Which quadrant am I in?
Oh, 4? 3.
Third. So is it positive or negative? Is my y? Yeah. So there we go.
Sorry, I don't know why I said 4. I think
Remember your pieces of this little puzzle here. Your amplitude is the absolute value of A, which actually it starts with A. So your amplitude is the absolute value of A. This guy is A. All right. Your period is 2 pi over B. This guy is B. All right. Your phase shift is negative C over B. This is C. And your vertical shift is just D. And that guy is D. So for this one, your amplitude is just 1/2 A, right? Your period is 2 pi over 4, which is just pi over 2. All right? Your phase shift is negative pi over 6, so positive pi over 6 over 4. All right? Which when you have a fraction over a whole number, you can just multiply those, or you can do keep, change, flip. Pi over 6 times 1 over 4, which is pi over 24. Your vertical shift is just D, which is negative 1. And then I'm not going to make you graph it. All right. So you just have to know those 4 pieces. If you have like the side angle side and you don't have any opposite, you're going to have to use your law of cosines, which is your sides that you have squared minus 2 times your side length times the cosine of the angle that you have. All right. Law of sines. He's a little bit easier. That says that your sine of each side over the opposite, sine of your angle over the opposite side creates a ratio, right? All right, so those are 291 and 293, I think. So like for this guy, if they want us to solve everything, that means they want the measure of angle A, the measure of angle B, and the measure of angle C. They want the side length of AB, the side length of BC, and the side length of AC. All right? So you can fill in what you have. You know angle B is 121 degrees. You know A to B is 29 centimeters. You know B to C is 24 centimeters. So we just need A to C. So we're going to use law of cosines for that one. We're going to say A to C, right? We're just going to label that here. This guy, opposite of B, and it's actually squared. So we're finding B. So we're going to say B squared, which we don't know, should equal the 2 side lengths we do know, minus 2 times the side lengths, and then the cosine of the angle that's in between them, 121. So you're going to put all that into your calculator and take the square root is basically what you're going to do. You put all that in and take the square root, you get 46.2, which means we have this guy right here. Now they need angle measurements. Well, now I have a side and the angle opposite. So now I'm going to use law of sines because it's easier, right? Does that make sense? So now I'm going to flip to law of sines because it's just easier to use. It doesn't matter. So let's say I want to solve for angle A. The sine of angle A over 24 should equal the sine of angle B, which is 121, over my side length of angle B, 46.2. All right? Remember when you're solving for an angle, what do you do in your calculator? Anytime you're solving for an angle, inverse. So in your calculator, you can say inverse, because remember you're going to multiply this across. All right, of 24 times the sine of 121, close those, divided by 46.2. So you can put all that in your calculator because you're solving for an angle. All right. So angle A, when you put it in your calculator, is going to be 26.4. All right. Now what do you think I'm going to do to solve for my third angle? You could. There's actually an easier way. You have 2 out of 3 angles in a triangle. 180, right? So they add up to 180. So yeah, now I can say, well, I have 2 out of 3 angles. I'm just going to subtract from 180 and get my third guy. So do the easiest method that you can and solve it. Like if you had started out with an angle and the side opposite, I would have gone straight to law of sines. Does that make sense? And then solved it that way because that would have been easier. So if I had an angle and a side opposite and I was solving for one of my other sides, I would have done that and I would have just solved back into it. All right. And then formula here when I'm trying to set area. So normally you would say area of a triangle is 1/2 base times height, right? But I don't have base and height. So this is Heron's formula. Heron's formula is S minus A, S minus B, S minus C, and S is 1/2, well, my perimeter, right? And so once you find the perimeter, you literally just say, okay, 1/2 perimeter, 12.6 plus 9 plus, I don't need that, plus 6.3. Once I get S, so that's 13.95. All right. Once you get that, you literally just plug it into your formula. So I know what S is. My area then of this guy is going to be the square root of 13.95. That's my S. Times 13.95 minus 9. Times 13.95 minus 6.3. Times 13.95 minus 12.6. Like you literally just plug it in. So, and then when you get it, you get 26.7 for your area of that triangle. You need to know your reciprocal. So if you need to know that sine is the reciprocal of cosecant, like you need to know your reciprocal ones. Okay, so you need to know those guys. Oh, I guess I should write it the same way I've been writing it. All right. All right, so you need to know your reciprocals. You need to know your quotient. Tangent is also sine over cosine, which means cotangent is cosine over sine. And then you need to know your Pythagorean identity. Sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. And 1 plus cotangent squared is cosecant squared. Right? So those are the ones you need to know. Okay? All right, so let's look at what they gave us. When they give you something like this, your first goal is to figure out what quadrant you're in, all right? So what quadrant are you in is what you want to figure out first. So I'm going to look here, and I'm going to say, what did they give me? Cosecant, that's reciprocal of which one? Sine, right? So they told me cosecant is positive 5/3. Sine is your y value, remember? So y is positive here and y is positive here, right? So if my cosecant is positive, so is my sine. So they narrowed it down to the first and second quadrant, right? By telling me that. Then they said cosine is also positive. So between those two quadrants, where's my x also positive? First quadrant. So they have told me that I am in the first quadrant. What are they asking for? Cotangent. That's x over y. If I am in the first quadrant, my cotangent is positive. They are also asking for secant, which is reciprocal of cosine. So that's also going to be positive. So the very first thing you're asking is, what quadrant am I in, to know if I'm going to give a positive or negative answer when I get done with these, okay? And then you're going to say, what did they give me and what do I need, all right? They gave me cosecant. They want me to find cotangent and secant. So I'm going to look at all of my identities and say, do these help me? Well, cosecant will help me find cotangent. Why? Because 1 plus cotangent squared equals cosecant squared, right? Cosecant will also help me find secant because the reciprocal of cosecant is sine, right? And I can, if I find my sine, I can use that to find my cosine, which is going to give me secant. Or if I find cotangent, I can use the reciprocal of that to find secant using this guy. Like there's a multitude of ways to get to secant from cosecant, okay? I can flip this and say sine squared plus cosine squared equals 1 and flip that guy to get him, right? I can go straight from here to here and get that and flip that answer to find secant. Does that make sense? So once you have the pieces, you can use their reciprocal as well. I have cosine, that means I also, cosecant, that means I also have sine. So I can use that to help me. Or I can use this and then flip my answer to use that and find the secant. Like there's a multitude of ways to go around to find this once you have the pieces that you need, okay? So I would probably start by finding cotangent because I have cosecant. So I would start with my 1 plus cotangent squared equals cosecant squared. I'd probably start with that one. So I would say 1 plus cotangent squared, which I don't know, equals, I do know cosecant, so 5/3 squared. Plug it in. So 1 plus cotangent squared equals 25/9, right? Subtract 1. When I subtract 1, common denominator is just denominator over denominator, right? So cotangent squared equals 25 minus 9, which is 16/9. I'm going to take the square root. So square root of 16 is 4, square root of 9 is 3. I've already determined that my cotangent is positive, right? So this is my cotangent. I have solved for it. Right? I am done with cotangent. Now I need secant. So I could go, if I wanted to, I can actually go here. 1 plus tangent squared equals secant squared, right? Because I technically also know tangent. If I know cotangent, I can just flip it. So I could say 1 plus tangent squared, which is 3/4, equals secant squared, right? Because if I know cotangent, I know tangent. So I have 1 plus 9/16 equals secant squared, right? Scooch the whole thing up. And here, again, common denominator, 16/16 plus 9/16 equals secant squared. 25/16, take the square root, I get 5/4. I've already determined that I'm in first quadrant, which means everything is positive. So I am done with that one as well. We're trying to prove that these equal your negative cotangent squared. When in doubt, make sure, put them, like the left side's more difficult than the right, so leave the right side alone and break the left side into sine and cosine. All right? So cosecant, how would I write that as sine or cosine? 1 over what? Yeah, so -1/sine times cosine is already in sine or cosine, so leave it alone. All right? When I multiply, I just multiply, so that's basically over 1. So negative cosine x over sine x does equal negative cotangent of x. Right?
Right, because
You just multiply across.
you get cosine over sine.
Right.
Makes sense.
So look at the next one. 1 over cosines. So, and I would actually split this up. All right. That's the same thing as 1 over cosine squared times 1 over sine squared. What is 1 over cosine squared? That is secant squared. This is cosecant squared. I can just reverse the order.
Okay. And it's okay.
And I'm done. I am going to get the trig by itself. So I'm just going to add this 8 cosine squared of theta to both sides. All right, just like an equation. That cancels. I have a 1 over here. Negative 4 plus 8 is positive 4. Right? Makes sense? Divide both sides by 4. Cosine squared equals 1/4, right? Take your square root. So cosine is positive and negative 1/2, right? Square root of 1, square root of 4. So now we're going to think about on the unit circle where my cosine is 1/2. My cosine is 1/2 where? Just think about the first quadrant. So let's say you remember it's a 60-degree angle. You can do pi over 180, right?
Okay.
Right, and that's pi over 3. So yeah, it's going to be a pi over 3 angle here, right? But it's also going to be a pi over 3 in the next quadrant, right? Because it's positive or negative. So this is what, 4 pi over 3? Or 2 pi over 3. All right, so just do your pi over 3s. Pi over 3, 2 pi over 3. 3 pi over 3 gives you this, so this is 4 pi over 3. And 5 pi over 3. Like all your pi over 3s. Because it's positive or negative. Had it been just positive, you would have only given me where your cosine's positive, right? So you would list all of your pi over 3 answers there. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Because it's the positive or the negative.
Right.
So when it looks like this, remember the sine of A plus B is sine A cosine A plus cosine A sine B, right? Oh, not cosine B, right? Remember?
Isn't that your sum and difference?
That's your sum and difference. And then cosine is cosine, cosine, sine, sine.
Right.
But remember, it's the opposite. So if it's plus, it's going to be minus. If it's, you know what I mean?
Yeah.
So for this one, this is your sine, right? Sine, cosine, cosine, sine. So this just means that this is going to be the sine of those two added together. Pi over 18 plus pi over 9, right? Common denominator. Multiply this by 2. So sine of pi over 18 plus 2 pi over 18, right? Which gives you the sine of 3 pi over 18, right? Which gives you the sine of pi over 6. So that's 1/2. That's a 30-degree angle. Helps to use the right one. If it has a variable in it, you're not going to give me a final answer. You're just going to give me tangent of something. So you just have to know, by the way, this is parentheses here. So remember tangent follows on the top. So this is your minus. So this is the same thing as the tangent of negative 6x minus x. Right? So that's negative 6x. So this is the tangent of negative 7x. Like this is just simplifying. You're not going to actually have a final number answer. It's going to have a variable in it. Okay?